Find all solutions of the following equation. Looking at this equation, I see that there are some common factors in the first two terms as in the second two terms. So I might pull out those common factors. I can pull out a 2x squared from the first two terms, leaving an x plus 1. If I pull out an 18 from the second two terms, I'm also left with x plus 1. This is a step known as grouping. And now, because of the distributive property, I can actually group these as 2x squared plus 18 all times x plus 1. This still equals 0. Now looking at the first two terms, 2x squared plus 18, I realize I can pull a 2 out of both of those, leaving x squared plus 9, still times x plus 1. Now I'm going to look at each term and set it equal to 0. Now 2 isn't really a term. I could divide everything by 2 and get rid of it, but instead I'm just going to set x squared plus 9 equal to 0 and x plus 1 equal to 0. Now subtracting 1, if I'm looking at the x plus 1, I get x equals a negative 1. And that's easy. But if I subtract 9 on the other side, I have x squared equals a negative 9. Whenever I have something squared, I would take the square root of both sides, getting x equals plus or minus the square root of a negative 9. Well, a little side note here. The square root of a negative 9 could be written as the square root of a 9 times the square root of a negative 1. Square root of 9 is 3. And the square root of a negative 1 is our imaginary letter I. So therefore I see that x equals plus or minus 3i. So my final roots are x equals a positive 3i, a negative 3i, and negative 1.